Okay, so problem number 4. Ian is playing Scrabble. What is the probability that the next 3 letters he draws from the bag spell out his name in the order that he draws them? Assume there's one of each letter in the alphabet bag left. Okay, so as with the problems we did earlier, numbers 1, 2, and 3, let's figure out if this is a permutation or a combination. And again, it's all about that question, does order matter? And there's kind of a hint in here. They say, what is the probability that the next 3 letters he draws from the bag spell out his name in the order that he draws them? So order does matter here. They're telling you that order matters. We're trying to see if when he pulls those letters out of the bag, does he pull out an I, followed by an A, followed by an N, in that exact order. Not N-A-I, not A-I-N. They want the order that his name is spelled. So pulling out an I, followed by an A, followed by an N. And like I said, order matters, so these are permutations. So we're going to be using the permutation formula if needed. So, again, sorry, let me fix the cursor. There we go. On top is, what are we trying to figure out? What are the number of ways to choose an I, an A, and an N from the bag in that order? And then the bottom number is the total number of ways to choose 3 letters from the bag, right? We're concerned with the probability of these 3 specific letters in this specific order, but for the bottom number, we just want to know the number of ways to choose any 3 letters in any of the orders. All right, so back to the top. And how many ways can we choose an I followed by an A followed by an N? So just a quick note, in this problem, if you go back to the directions, it says, assume there is one of each letter in the alphabet bag. So there's one letter from A to Z. That means there's only one A, there's only one B, there's only one I, there's only one N, so on and so forth. So how many ways can we actually choose the letters I, A, and N in that specific order? There's only one way to do that, right? And once you choose those letters, they're out of the bag, they're gone. You can't choose them again because there's only one of each letter in the bag. It'd be different if there was like 3 I's and 4 A's, right? But that's not the case. There's only one letter in each bag, one of each letter in the bag, and there's only one way to pull out I, A, and N in that specific order. So, top number is 1. Now on the bottom, how many ways can we choose those 3 letters? So, I know I wrote choose, but we could also just say pick. Because again, this is a permutation problem. Order is going to matter. So how many total letters are there in the bag? 26, right? And how many are we trying to pick out in a specific order? 3 of those. So 26, pick 3. So from here, you can plug that into your permutation formula, or you can figure it out on your own by drawing a picture. What I can tell you is that you should end up with 15,600. That's your bottom number, and then the probability overall, 1 divided by that, is 4 zeros, and then a 6. So 0.00006. Which is a very small probability, which makes sense. If all those letters are shuffled around in a bag, what is the probability that you pick out an I, and then an A, and then an N in that specific order. It's highly unlikely, very close to zero, that that will actually happen. Okay, so number 5. William and Gavin are going to watch 2 movies after work. Together they have 30 movies. If they decide to randomly choose 2 movies, what is the probability that the 2 they choose will consist of each of their favorite movies? Assume they have different favorites. Okay, so again, is this a combination or permutation? If you read that problem again, they're focusing on just choosing the movies. They're not talking about watching them in any specific order or picking them in any order. There's even no mention of order. So this is going to be definitely a combination problem. So no permutation formulas here. All right, we want to figure out the probability that they pick their 2 favorites. And we're assuming that they don't have the same favorite movie. They each have a different favorite movie. Okay. So on top is the number of ways they can choose their 2 favorite movies. So again, order isn't mattering here. So like, who was it? William and Gavin. So put W for William and G for Gavin. So suppose we pick William's favorite movie first, and then we pick Gavin's favorite movie, right? Because order doesn't matter here, that's technically the same as picking Gavin's movie first and then picking William's favorite movie. So these 2 things are the same. They don't count as 2 separate situations. So in how many ways can they choose their 2 favorite movies? There's only one way. And it's if they pick those 2 exact movies. Again, it doesn't matter which one they pick first, as long as they pick the 2 favorite movies. Now on the bottom is the total number of ways to choose 2 movies from the whole movie collection. So we're not focusing on just their favorites. It's out of all the movies. And there were 30 movies. 30. And then we're choosing just 2 of them. So once again, work out that 30 choose 2. You should get 435. You can type that just like that into Hawks, or find the decimal, and I went ahead and rounded it. It's 0.00230. That's rounding to 5 decimal places.